Hello everyone. Today we are going to be learning about exponential growth and decay functions, but we are going to be looking at word problems. Prior to this, we've learned about exponential functions and the different parts that make up an exponential function. The initial value, the growth factors, the rate, the time. Today we're going to take all of that and put it together as we work through some word problems. Okay, so the first word problem we're going to look at is on the board. You can read it with me. You invest $2,500 in the bank, which pays 4% interest per year. What will be the value of the investment after 10 years? Okay, so the first thing we have to think about is the different parts of an exponential growth and decay function. So we know that when we create a growth or decay, we're going to start with our A, which is our initial value. We're then going to do times 1 and then a plus or a minus sign, depending on if it's growth or decay. We'll then subtract or add that rate, and our exponent will be our time, how many years. So the first thing we can see is that our initial rate is that we are investing $2,500. So when I'm creating this, I'm going to write Y equals 2,500 because that is my initial amount of money. All right, so then next we're going to determine, is this a growth or a decay problem? Now, considering we're investing money into a bank and it's going to be giving us a 4% interest rate per year, that's a good thing. So in this problem, we're actually going to be adding because this is growth. We're going to watch our money grow in the bank. So I'm going to put 1 and then a plus sign. Now, what you have to do is we have to take this 4% and we do have to convert it into a decimal. We do not want to put 1 plus 4, okay? So remember, the easy way to make a decimal of percent into a decimal is you put the little decimal point here and we move it 2 times. I put a 0 and now we have 0.04. So I'm going to put that right in here, 0.04. Okay. Now in this problem, we are trying to find how much money we are going to have after 10 years. So that time that we have here as our exponent, that's going to be our 10 years. We want to see after 10 years, how much money are we going to have? Okay, so now that I have my function all set up, we are going to start by simplifying a little bit. We are going to write Y equals 2,500 times, now 1 plus 0.04 is just 1.04, and I have an exponent of 10. This is now going to be easiest using a calculator. Okay, so I just want you to see how I inputted this into my calculator. 2,500 times 1.04, all in parentheses, raised to the 10th power. When I press enter, I get this large number, 3,700.610712. So I wrote the answer we got on the calculator on the board, 3,700.610712. Now, we want to put this in the context of the problem. We are talking about money here, and we're looking to see how much money we would have after 10 years. When we look at our bank accounts, we don't see this much sense in our bank account, so we do want to round this. So we're going to make this $3,700.61. So this will be our final answer, okay? So initially, with $2,500, if I have a 4% interest, after 10 years, I will have $3,700.61 in my bank account. All right, we're going to do one more problem now. So as you see, I have a new problem on the board. Daniel bought a brand new car for $22,000. Each year, it depreciates at a rate of 8.5%. How much will the car be worth in 6 years? So on the board, we see the growth or decay formula, Y equals A times 1 plus or minus the rate to the power of t. So we have to determine if this is going to be a growth or a decay problem. So what gives that away is we're going to use our keywords here. Now a car, if it's depreciating at a rate of 8.5%, that means it's going down. All right, so this is going to be a decay problem. So we know that in this problem we are not going to be adding, we are going to be subtracting. Okay, so now let's find all the important parts. First, we need our initial amount. How much does the car start at? Well, the car started at initially $22,000 when it was brand new. So Y equals $22,000. Now I'm going to put 1 minus because we already decided that this was a decay problem. When we depreciate, we are going down. Again, now this has a decimal point, right? This is my rate, okay? So R equals 8.5%. Just because you see a decimal doesn't mean you still don't have to convert it. Again, when we have a percent, we need to move the decimal point to the left. Okay, so I'm going to take this decimal point, I'm going to move it to the left. So this really becomes 0.085. It's very important to keep that in mind. So that is what I'm going to put over here, 0.085. All right, so now we are going to simplify what's inside the parentheses. As you see right here on the calculator, I did 1 minus 0.085 and we get 0.915. All right, so the last thing we have to fill in is the time for our exponent. So again, we are trying to find out how much the car will be worth in 6 years. So I'm going to put a 6 as an exponent. At this point, we simplified as much as we can. We're gonna go ahead and plug this entire thing into the calculator. Okay, so here we see I inputted into the calculator. 22,000 was our initial price of a brand new car, times 0.915 to the exponent of 6 for 6 years. I'm going to press enter and we're going to get 12,910. Now again, looking at this, we are talking about money, so we are going to have to round this to the nearest cent. We do not want to have 0.68381. Okay, so I wrote the number that we got on the calculator on the board. Now I am going to round it because we're talking about money. So we are going to round to the nearest cent. So we are going to say that in 6 years, this brand new car is now going to only be worth $12,910.68. Okay, now this makes sense that it's not more money because remember, cars depreciate in value. So each year it's depreciating more and more. So a brand new car that was originally $22,000 after about 6 years may only be worth $12,910.68. I hope these 2 word problems helped you, and now you are ready to work on your own on growth and decay word problems.